Hey everybody, welcome to advanced integrals of trigonomic functions. So we're going to continue our discussion on taking integrals involving trig functions. So I've got 4 examples to show to you. I'll try to do it in one video. I may do it in a couple videos. Okay, so again, flipping with Bennett here. So let's go ahead and get started. Now these can be pretty tricky to do, and depending on some of the rules that we have. So we're going to go ahead and evaluate integral of sine cubed of x. Okay, so let's go ahead and look at how we would do that. Okay, so a lot of these you're going to have to start by rewriting and using using substitution. So I'm going to go ahead and just at least rewrite my integral here. So we've got sine cubed of x dx. Okay, I can simplify that. I'm going to rewrite this as sine of x times sine squared of x. Okay, so I just rewrote my integral. Okay, my integrand. So I go ahead and do that. And my next step is going to be substitution. I'm going to leave the sine of x alone because there's nothing I really can do there. Okay, but we know that by the Pythagorean identity, sine squared of x is equal to 1 minus cosine squared of x. So I went ahead and I did a substitution there. Okay, so once I do the substitution, I'm going to go ahead and simplify. I'm going to go ahead and I'm going to multiply out. So I get sine x minus sine of x cosine squared of x. Okay, and that's dx. Okay, so I distribute through. So now what I'm going to go ahead and do is I am going to separate the integrals. And I have sine of x dx minus the integral. I'll put the cosine squared x out front of sine of x dx. Okay, now depending on what you know about this particular function, this is a property. Okay, this is one of our integral properties, and it's actually, if you have cosine, I'm going to go ahead and write it over here. My face is in the way. So cosine of nx times sine of x dx. If you have that rule, it's just this. Cosine of n plus 1 over n plus 1 plus c. Okay, that is the answer to that question. Okay, so that is a rule. If you don't have that rule, you can go ahead and use substitution, but I'm going to follow this rule here. So I'm going to integrate. What function gives me a sine antiderivative, or a sine derivative, excuse me, would be negative cosine of x minus, I'm going to follow that rule now, and I'm going to have cosine, I'll say, of 2 plus 1 over n plus 1, that's minus, plus c. That's the integral of this piece right here. And so my final answer is cosine cubed of x, got the x there, sorry, over 3, so that'd be 2 plus 3 minus cosine of x plus c. And there's our first integral. There's our first solution. I just went ahead and rewrote that. Okay, so that's the integral of sine cubed. Let's go ahead and look at a few more examples here. Okay, so we'll take care of that one. And we're about 3 minutes. I'll probably turn this into 2 videos, everybody. Okay, so here is our next example, and we have evaluate the integral of sine cubed x and cosine squared of x. And this is going to be another one of those rules that we're going to be able to use. Okay, so I'll go ahead and rewrite this. So we have sine cubed of x cosine squared of x dx. We're going to go ahead and integrate that. And now we're going to do like we did last time. We're going to simplify this. And we're going to write this as sine of x times sine squared of x times cosine squared of x dx. Okay, so I just rewrote my integrand again. Okay, and what I'm going to do is do what I did in the last example. I'm going to leave the sine of x alone. I'm going to replace sine squared of x with 1 minus cosine squared x. And now I have cosine squared x here, all dx. Okay, so I rewrote my integrand, and now what I'm going to do is I'm going to use substitution. Okay, so I can go over here, and we're going to let u equal cosine of x. Okay, and that means du equals negative sine of x dx. Okay, and that means negative du over sine of x equals dx. Okay, so let's go ahead and rewrite our problem. So we're going to have the integral of sine of x Now watch what I'm going to do here. 1 minus u squared times u squared. And then we know that du is negative sine of x. And guess what? We're going to be able to make those sine of x as 1, bring the negative out front, that negative right there. And then we're going to be integrating 1 minus u squared times u squared du. So we're going to go ahead and multiply that through. Okay, we're going to multiply that through, and we get negative. We're going to have the integral of u squared minus u to the 4th du. Simple power rule now. So you get negative u cubed over 3 plus u to the 5th over 5 plus c. Okay, don't forget to plug in your u. So you got negative cosine cubed x over 3 plus cosine to the 5th, cosine 5 x over 5 plus c. Okay, so that's our first two examples on how to take the integral of more advanced trig functions. If you have any questions or comments, see me next time. We're going to go ahead and make a second video here in a second.